Hi class, this is Ms. Taraz here. In this video, I'm going to take a few minutes to solve an algebraic equation that I've noticed has been giving some students in my classes some difficulty. Here we have 42 hundredths minus 3 hundredths y equals 3 and 33 hundredths minus y. So right off the bat, I can see that this equation contains decimals. As we discussed in an earlier video, I'm going to take a minute to clear my equation of these decimals by multiplying the entire equation by a factor of 10. In this particular instance, because we are dealing with hundredths, we have 42 hundredths and 3 hundredths and 33 hundredths here, it makes sense to multiply the entire equation, or rather both sides of the equation, by 100. When I perform this operation to both sides of my equation, my new equation will read as 42 minus 3y equals 333 minus 100y. At this point in the problem, I look on the left side and I see that I have a term that contains a variable factor, y, and I also have an integer, 42. On the right side of the equation, I have 333 minus 100y. At this point in the problem, I know that I need to collect my variable factors on one side of the equation. Now, this is where I think some students are running into some confusion. So, before we decide how we are going to either collect my y terms on the left or the right, I want to take a minute to clarify something with all of you. When you look at terms in these sorts of algebraic equations, I want you to understand that whatever symbol is directly to the left of any term, that symbol is essentially attached to that term. In a way, I could actually draw a box around my 100y and include the subtraction sign that is in front of the 100y to reinforce this idea that minus 100y is a unit. I can't separate my 100y from the subtraction sign. Similarly, I could draw a box around the 333. However, in this instance, there's no symbol in front of my number. It simply stands alone. I'm looking at 333. It's important to remember that, in fact, 333 has a positive sign in front of it. We don't draw it in typically, but it does exist. On the left side of the equation, I could draw similar boxes. Around my 3y, I would include the minus sign that is immediately to the left of it. And I could also draw a box around my 42. And again, just like the 333 on the right, there is an understood plus sign. So if it helps you to remember what operation you need to perform to move a term from the left to the right or vice versa, go ahead and insert these understood positivity signs in front of numbers that begin an expression on either side of the equation. So from here, I need to make the decision about where I want to collect my variable terms. Since I have minus 3y over here and I have minus 100y over here, I think it makes sense to move my variable terms to the left side of the equation. To accomplish this, I'm going to look at my 100y and pay very close attention to that symbol in front of it. I see subtraction. So I'm going to perform the opposite or inverse operation, that is addition, to both sides of the equation. I will add 100y to both the right side and to the left side of the equation. Okay, when I do that, the y factors on the right side of the equation equal 0. Minus 100y plus 100y equals 0. So I have successfully simplified my right side of the equation. I'm left with simply 333 plus 0. On the left side, I now have minus 3y plus 100y. When I add 100y to minus 3y, I am left with a positive 97y. And then in front of that, I'm going to add the 42. Just pull that down from the equation above. So let's take a minute to clarify exactly what just happened here. I had minus 100y on the right side of the equation. I made the decision to move this term to the left side of the equation so that I could collect all of my y terms on the left side. I took a minute to look at the sign in front of this factor. I saw that I had subtraction, so I performed the opposite operation, or the inverse operation, addition. I decided to add 100y to both sides of the equation, to the right and to the left. When I added 100y on the left, I took into consideration the symbol in front of my 3y. I thought to myself, minus 3y plus 100y equals 97y. It's very important that you take note of this step right here, because several students I've noticed would be inclined to combine these terms as 103y, and that would be incorrect, and that would ultimately lead you to a false solution. So from here, I now need to get my 42 away from my 97y, because as we all know, the goal is always to isolate the variable. So I will, again, I have to actually take a minute to remind myself that in front of this 42, there is an understood plus sign. So to remove this 42 from the left side of the equation, I must perform the opposite operation, which would be subtraction. So I will subtract 42 from the left, and I will also subtract 42 from the right. When I do that, I'm left with 97y equals, and now I need to take a minute to do some mental math, 333 minus 42, that equals 291. From here, I now need to look at the coefficient in front of my variable, or my unknown value. I have y multiplied by 97 equals 291. To isolate the variable in this situation, I need to perform the opposite operation, which in this case would be division. So I will divide both sides of my equation by 97. When I do that, my quantity y multiplied by 97 divided by 97 leaves me with 1y, which I can express simply as y. And then I have y equals 291 divided by 97, which conveniently works out to equal 3. So at this point, I have successfully solved the equation. Let's take a minute to go back and recap the moves I made to find the solution. So I started out with an equation that contained decimals. I took a minute to quickly multiply everything by 100 to wipe out the decimals, and I had a new equation that I could express in the form of 42 minus 3y equals 330 minus 100y. From at that moment, I took some time to explain to you how it can be helpful to draw boxes around each term in your equation, making sure to include the symbol that is directly to the left of your term. In instances when you have a positive term on the left side of an expression, there may be no symbol in front of it. If it helps you to keep your understanding straight, you can go ahead and add in a plus sign just to remind you that this number is positive. At this point, I decided to add 100 to both sides of the equation so that I would be able to collect my variable terms on the left. My new equation read 42 plus 97y equals 333. I then decided to subtract 42 from both sides to again work towards my goal of isolating my variable. At this point, I had my equation simplified down to 97y equals 291. From there, I performed the inverse operation of multiplication, that is division, to both sides of my equation. I divided both sides by 97y to clear the variable of the coefficient. I was left with y equals 3. So at this point, I will just simply draw a box around my answer to show that it is my final answer. So if you have any questions about this video, please take a minute to record them in your math journal or come to class prepared with questions to ask me directly, or you could go back and watch the video again to see if you could perhaps clarify any areas of confusion or misunderstanding.